So additional topics number 4 is on absolute value functions. So we've talked a little bit about integrating absolute value functions when we talked about distance versus displacement. Do you guys remember?
Yes.
So now we're going to talk about actually integrating absolute value functions without a calculator. And the reason this is important is because this is on the Calc AG test a lot. It's usually on the multiple choice section. So you guys will need to know this for your upcoming exam. No, on the non-calculator section.
Oh.
All right, so sketch rough graphs of the areas represented by the integrals without using a calculator. Solve. All right, so if I have 2x minus 3, the way that we're going to graph this is we're going to think of the function y equals 2x minus 3, which is a line. And we're going to graph that first. So 2x minus 3 means I have an intercept, a y-intercept of -3, a slope of 2. So go up to right 1, up to right 1. Okay, so we would have, I'm going to draw it in dotted lines. We would have this line here. Okay, now what is different about absolute value of all of that? What does absolute value of a number mean? Yeah, it's not going to go below the x-axis. Everything's going to be positive, right? So this line that I had before, the part that's down here is now going to flip up over the axis so that all of the y values are now positive. So that's how we get our absolute value shape. Okay, mine's drawn really bad. You can't tell where it goes through. Can you guys tell where it goes through? The axis?
3.
Yeah, it should be 3 over 2. And the reason is because this point is where 2x minus 3 is equal to 0. It's where the y value is 0. Add 3 over, divide by 2, you get 3 over 2, or 1.5. So right between the 1 and the 2 is where your v starts. Okay, now the question is, if I'm going to integrate, so if I'm going from -1 to 5, what does that look like on my graph? So if I'm integrating something, what am I doing? I'm finding the area under this curve that I just drew. So between the curve and the x-axis, from -1 to 5. Mine is terribly not drawn well. It's terrible. Okay, it's not symmetric. It's much higher on this side, right? Integration was just summed up for you in a sentence, Evan.
No, like absolute value stuff.
Okay, I see.
Why we did that earlier.
Yeah, why they were positive. Okay, so we end up with 2 triangles. So what we need to know are these highest points of our triangles. So if I plug in 5 into the absolute value of 2x minus 3, what do you get? 7, right? If I plug in -1 into the absolute value of 2x minus 3, you get -5 in absolute value, so 5. So those are my 2 points. So -1, 5, and 5, 7. So that means my area of my triangle on the right is 1/2 base. What's the distance along the base? It started at 1.5, right? And it goes to 5. Yep.
3.5.
Base. And then the height is 7. All right, so this ends up being... Nope, because we're just doing the one triangle on the right.
Oh, the one on the right.
Yep. Okay, you end up with 12.25. Okay, now how about the triangle over here on the left? It's 1/2. What's the base for this one? 2.5, right? Because it's from -1 to 1.5. So 2.5, and what's the height? 5. So you end up with 6.25. So that means if I'm integrating from -1 to 5 of the absolute value of 2x minus 3, you end up with 6.25 plus 12.25, so 18.5. And that's it. Okay, I'm going to give you guys a chance to try number 2, so start number 2. Oops. All right, so a lot of people in the first class messed up on the graph, so make sure that you're thinking about what y equals negative x plus 2 looks like. So you go up to 2, and it has a negative slope, so negative 1, go down 1, right 1, down 1, right 1, down 1, right 1, right? So here's the line that you're originally talking about. And we want it to only be the positive version of that line. So now anything that was below is now going to pop up. So here's my absolute value function. All right, I'm going to go from negative 3 to 4. So you should have a little triangle on the right, big triangle on the left. Everybody get that? Yeah, some people in the last class had like upside down V's. I don't know. Maybe because they were doing like negative absolute value of x plus 2 or something. Okay. So let's see. What'd you guys get for the area of the big triangle?
Well, it's weird because like when you plug in negative 3 into the absolute value.
Oh, you plugged in negative 3 to get the point? Yep. What'd you get?
5.
5. And then what'd you get for the other one? So you plugged in 4? 2. Okay. So that means area equals 1/2. Base is, let's see, 5 units. And height is 5. So 25 over 2 or 12.5. All right, and then the area of the triangle on the right is 1/2. Base is 2, height is 2. So it's just 2. So you should get 14.5 for your answer. Did you guys get that? Okay, good. Now let's try some trickier ones. Yeah. All right, if you guys remember from Algebra 2 our math aerobics, do you guys remember math aerobics? Yeah. So transformations, in other words. You guys will be fine on 3 and 4 because you can graph this so simply. Okay, so here's what I do. Okay, I think about if it had just been absolute value of x. I know that's a V shape, right? What if I have absolute value of x minus 5? What happens to that V shape?
Goes down 5 units.
Nope, not down. It goes right 5.
Right.
Yep, because it's not at the end of it, right? So it's inside with the x, it's going to go right 5. Then if I have a negative out front, what happens? Yep, so it's a reflection across x-axis. So right now I had my V shape. I'm going to go right 5. I'm going to reflect across the axis. So I'm now down here. And then what's the last thing? So yeah, I have negative x, or negative absolute value of x minus 5, and basically with a plus 5 tacked on. So that means up 5. So your final answer is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's going to be right there. And it's going to be going down like this. Okay, but let's say you forgot your transformations, which is fine. So if you forgot them, how do you graph something if you don't know what it's going to look like?
Plug in x, y table.
Yep, do a t-table. All right, so we're going to do a t-table. So let's say we didn't know all of this up here, and we had to use a t-table. So let me go ahead and just erase it. Pretend we never did it. So if I didn't know, then I would plug in numbers like 0 would be a good number. Other numbers that are good for absolute values is you always want to think about what's going to make your absolute value as small as possible. So the smallest thing an absolute value can be is 0, right? So what x value makes it 0? 5. So you want to plug in 5. And then you also want to plug in numbers on the right and left of that number. So try 6 and 4. Because that ends up being where the V shape is, so where the point is. So like the point of your absolute value, the corner point. Okay, so if I plug in 0, I have 5 minus, it ends up being 0 minus 5, so 5. So you get 0. If you plug in 5, you have 5 minus 0, so 5. If you plug in 6, what do you get?
4.
4, right? Because it's 6 minus 5 is 1, so 5 minus 1 is 4. What about 4? It's also 4, right? Okay, so we need 0, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5, 5, 6, 4, so just a little bit down, and then 4, 4. Okay, I can tell it's going to be an absolute value that's upside down. Oops, I'm going to make that a little bit better. Because I had a negative out in front of my absolute value. So I know it's going to go upside down. Okay, what point should it cross at? across the x-axis? 10, exactly. How'd you know that?
Because
It's symmetric, right? Is that the word you're looking for?
yeah.
I saw the fingers, yeah. It's symmetric. So if this went through 0 and it was 5 units away, this is going to be 10. Okay, so if I'm integrating from 3, so 1, 2, 3, to 8, 7, 8, here's what I have. Kind of a weird shape. Yeah, it's 2 trapezoids. Do you guys see the 2 trapezoids? You could also do this another way. You could take the whole big triangle from 0 to 10 and then subtract out the 2 little triangles on the side. You could do that as well. Okay, but I think it's good to review trapezoids because why do I need to know trapezoids for my AP test? The trapezoid rule. So it's a way to approximate, kind of like Riemann approximations. So the rectangles are Riemann, trapezoid rule are trapezoids. All right, so let's talk about the one on the left. If you remember your trapezoid area is 1/2 h times b1 plus b2. You need to know that. If you don't know it, put it on a flashcard. So I'm going to have 1/2. In this case, what's h? 2. H is on its side, right? Your trapezoid looks like this. So when you talk about the distance between the 2 bases, these are called our bases, the parallel sides, that's your height. So in our case, it's 2. B1 and B2, it doesn't matter which one's which. Can you guys tell what they are on your graph? I can't really tell. So if I plug in 3, what was it? 3 and 5? And then this one is, if I plug in 9, 1. Okay, so I have 1/2. H is 2. B1 plus B2 would be 3 plus 5. So I get 8. Then my area of the second trapezoid is 1/2 H times B1 plus B2. So it's 1/2. In this case, my H is 3, it looks like, right? And B1 is 5 and B2 is 1. It doesn't matter which one's which. Oh, it's 2. Thank you. So you plug in 9.
It's 8.
Oh, it's 8 that we're going to. Thank you. I was like, I thought I'd plug that in. Okay. So you get 2 here. All right, so you end up with 21 over 2. Plus 8, so 18.5 is your total area. I kind of wrote that bad, but okay, makes sense? You guys up for the second one? You gonna try it? All right, go and try 4. Okay, you guys should get a pretty weird shape. Did you guys get a weird shape? All right, so it should be going upwards, right? And you're going from 0 to 6. So let me, oops. Let me go all the way to 0 so you guys can see it. So you have here, and then 5, 6, there. So what do you guys have?
2 trapezoids.
Yep, 2 trapezoids again. Okay, so the area of the big trapezoid is 1/2 height. Your height in this case would be 4. Times, what is it, 2 plus 6? Did you guys get that?
Mm-hmm.
So 2 times 8 is 16. All right, and then the area of the second trapezoid is 1/2. Height in this case is 2, so that's that horizontal distance. And then 2 plus, what was the other point? 4 when you plug in 6, yep. So you get 6. So you get 16 plus 6 is the whole area, which is 22. So 22 should be your answer. All right, so let's try even harder. Okay, so on this one we have a parabola shape, right, originally. So what you're going to graph is the parabola that looks like y equals x squared plus 2x minus 3. Okay, so important points on the parabola. You could find the vertex. Do you guys remember how to find the vertex of a parabola?
You take the derivative and solve for 0.
Yep, or you could remember from algebra 2, it was negative b over 2a, right, for the x value. Do you guys know where that comes from? Quadratic formula. So this is my side note. So pay attention to the side note. It's a good one. So what Kinsey said is make the derivative equal to 0. Well, your derivative is 2ax plus b, right? So if it's equal to 0, you subtract the b over. You want to solve for x, negative b over 2a. That's where that comes from. You guys learned that in algebra 2. Calculus, man. Who knew it was useful? All right, so anyway. So you're going to factor. So you get x minus 1 times x plus 3. That equals 0. So x equals 1 and x equals negative 3 are the places along the x-axis where your y is equal to 0. So where your point crosses the x-axis. So 1 and negative 3. Okay, does your parabola go up or down? Up. So it opens upward because it's positive x squared. So here's the parabola that we would have without the absolute values. Do you guys remember using the word axis of symmetry? It would be directly between the two, right? So at negative 1. Okay. So that means that the piece that we are talking about, so since I said absolute value, you want positive y values. So anything that was below the axis is now going to flip up above the axis. Yeah, it's not a very nice graph because you don't have very nice straight lined shapes, right? You don't have trapezoids or triangles. You have strange shapes. Okay, these are curvy, right? They're not perfect lines. Okay, you're going from negative 4 to 2. All right, draw your picture. Shh, guys, you're getting a little loud. So draw your picture. That's what you have. Okay, now the reason you guys need to know how to do this. So obviously you guys can do this on your calculator, right? Yeah, let's go ahead and use Math 9 to find this answer. So let's see what it's going to be with our absolute value button and Math 9. And then we're going to do it by hand.
Would this be something that would be on non-calculator?
Yes, and I'll tell you why. Okay, so I'm going to do Math 9. I'm going to do Math, arrow over to number, hit absolute value. I'm going to have x squared plus 2x minus 3. Close your parenthesis for your absolute value. X, comma, negative 4 to 2.
15. 15.333.
Yes, so your calculator, remember we talked about like the bits and bytes and all of that of a calculator. Sometimes it can't handle all of the information that it's computing. This is especially true with Math 9 and Math 8, so the definite integration and the numerical derivatives. Are you paying attention, Tim? All right, so on your calculator, mine says 15.3333631. But what it's done is it has rounded somewhere and created this rounding error. The answer should really be 15 1/3. Okay, so that's why it's important to know how to do it by hand, but it's also important because the AP exam always has just the setup. Like a lot of times your choices, A through E, will look like integrals. It will say this integral plus this integral plus this integral. It'll be like this integral minus this one plus another one, and it'll have all the different setups. You know, so you guys need to know how to set up these problems without using Math 9 on your calculator. It's very important. Okay. So in this case, we go from negative 4 to negative 3. And it's just our normal x squared plus 2x minus 3 that we're finding the area under the curve, right?
Did you write negative 3? I don't know.
Yeah, it's negative. All right. But then what happens from negative 3 to 1? What did we do to our function? We flipped it up above the axis. So all of the y values now became opposite. So what we're doing is we're adding on the opposite. So you can write it as negative on the inside, but what I usually do is I pull the negative out to the outside. So I'm subtracting out the next one. So I'm going to have x squared plus 2x minus 3. Because if I integrate something that's below the axis, it would be a negative number. Okay, we're adding on the opposite. We're adding the negative number, or we're adding on that negative number. What am I saying? We're subtracting the negative number, which is adding the positive version.
Would it be wrong to just say plus the absolute value?
You could do that. So negative 3 to 1. Okay, and then you're adding on from 1 to 2. And this one was just the normal function, right? We didn't flip that piece of the graph. Okay. Yes, it is a pain in the butt to do by hand, so this is why something like this might just give you like the setup. But we can do it by hand. So we get x cubed over 3 plus x squared minus 3x. We're going from negative 4 to negative 3. Then we're subtracting out whatever we get with, see how you're really only integrating once? Negative 3 to 1. Go ahead and try this with me. Don't just wait for my answer. Okay, and you end up with a lot of fractions. So my suggestion is if you are doing this, I don't know, doing this, I say don't use Math 9 on your homework. So you can use like the calculator to add up your fractions if you want. But what I would probably do is do a lot of it in your head. If I plug negative 3 in, I get negative 27 over 3, which is negative 9, plus 9, plus 9. That's the first part. Minus, so now I'm plugging in the minus 4. So minus negative 64 over 3, plus 16, plus 12. So that's the first integral. See how this is going to work? So now we do the next one. A lot of these numbers will end up being the same. So 1/3 plus 1 minus 3 minus negative 27 over 3, so negative 9. It ends up being that what this was, plus 9 plus 9. Okay, and then plus, or minus, where am I? Yeah, plus. Okay, so plus, if I plug in 2, I get 8/3 plus 4 minus 6. Minus, if I plug in 1, 1/3 plus 1 minus 3. Some things cancel out.
Did they cancel?
We need a minus.
Yeah.
It shouldn't come.
In front of what?
Second, like grouping.
Well, I'm saying negative 9 plus 9 is 0, right? For each
No,
one.
the huge.
Like the big clump.
Big bracket. Second.
I need a minus here?
No, the other one.
The other one.
The one before.
I don't know. This one?
Yeah.
Okay. All right, so let's see. So 9 plus 64 over 3 minus 16 minus 12 minus 1/3 minus 1 plus 3 minus 9 plus 8/3. Tarek, how about you try? Well, welcome to calculus. All right, what did you guys end up getting? Did you get it? I messed up on mine. I know it's not the same answer I had in the first one.
15.33.
Yeah, 15. Only because you did it with Math 9 earlier when I asked you to. 46/3, right? So you should get 46/3. All right, so let's go ahead and skip down to number 7. Okay, number 7, it's important that you know your unit circle. If you don't know your unit circle, you won't be able to do this one. This is definitely something that could be on a non-calculator portion. Tim, are you paying attention? What did I say you should know? I was talking to you because you refused to learn it, right? I said Tim. All right. All right, cosine. What does cosine look like? So it starts at 0, 1. It goes down, it goes back up, right? This is what cosine looks like. Okay, let's think about where it crosses the axis. So if you remember your unit circle, so when are your cosine values equal to 0? Pi over 2, so this is pi over 2. And then at 3 pi over 2, so this is 3 pi over 2. Negative pi over 2. Negative 3 pi over 2. Okay, so we want to go from negative pi. What's the cosine value when we're at negative pi? So here's negative pi.
1.
Yeah, cosine is negative 1, right? Negative 1. So we're down here at this point. So we're going from there to pi over 6. Now, the way I'm drawing this is not all the way correct because what do I have in my problem? I have my absolute values. So what I drew down here, now where does it go? It flips up, right? So there's just two pieces that I need to integrate. So the first piece that I need to integrate is from negative pi to, what did we say that value was? Negative pi over 2. And it wasn't cosine, it ended up, we flipped it, right? So that was negative cosine of x. All right, we're going to add that onto from negative pi over 2 to pi over 6 of regular cosine of x. Okay, if I integrate cosine, what do I get? Sine. So if I integrate negative cosine, I get negative sine. So I'm going to have negative sine of x from negative pi to negative pi over 2 plus sine of x from negative pi over 2 to pi over 6. This is where I'm saying you need to know your unit circle. If you don't know it, you're going to be in big trouble on your test because cosine and sine are all over your AP test. All right, so the first thing I need is negative sine of negative pi over 2. Okay, and then I'm going to subtract out negative sine of negative pi. So I'm going to add sine of negative pi. Then I'm going to have plus sine of pi over 6 minus sine of negative pi over 2. Okay, so Alex said 1. So here's where negative pi over 2 is, down here. That ends up being negative 1, but I have negative 1. So 1. Plus sine of negative pi, here's negative pi. The y value on the unit circle is 0. Sine of pi over 6 is the angle that's real small. That means I go out further than I go up. So that's the point square root of 3 over 2 comma 1/2, right? So it's 1/2 minus sine of negative pi over 2. So again, that's down here. So it's minus a negative 1, so plus 1. So you get 2.5 or 5 over 2. Okay, that's your answer. Okay, that could definitely be on the non-calculator portion. You should know how to do all that. All right, so let's skip 8. Let's go to number 1. Okay, it says sketch rough graphs of the areas represented by the integrals. Write a new integral that does not use the absolute values and solve. You may use a calculator to help you. Okay, so like I said, on the AP test, a lot of times they don't give you the final answer. A lot of times they just say, which of these following setups is correct? This is why you need to do things like this. Okay, so on the very first one, I have x squared minus 6x plus 3. So let's look at what that looks like without the absolute values. So I'm going to have x squared minus 6x plus 3. Okay, we need to know what these points are, where it crosses. Do not assume that it's 1 and something else, right? You need to find the 0. So do second trace, left bound, right bound, guess. My calculator gives me 0.55051.026. Okay, what do I want to do? Store. So hit X, stow as A. All right, we always circle our letter so we know that we've stored it as that variable. All right, let's find the other one. So go to your graph, find the 0. Left bound, right bound. What'd you guys get? Yeah. So I have 5.4494897, somewhere around there. Let's store that as B. So hit X on your normal screen, store as B. All right, so if I was doing the setup of this, it would look something like, now remember, you're going to flip over the axis. So if I'm going from -2 to that first point, I'm going to have -2 to the A value. You can let this be your f of x. So we're going to say f of x dx plus, what happens with the next part though? Yeah, it has to be the opposite. So we're going to have negative f of x dx. And we're going to go from A to B. So you could just have a minus out front, it doesn't matter. And then the last one is just the normal f of x. And you're going from B to 8. All right, now if you guys are doing this, so if this was like a free response type problem and asked for the setup, remember different things you have to do. You have to let f of x be this, because we never had f of x on our problem, right? So we have to assign our function. We have to save our numbers as a and b, and then we can use those in the problem. Okay. You could easily do this with your calculator, but so let's say let's use Math 9. I'll just let you use the absolute value button since we're running out of time. Mine's thinking as you're thinking. Like 62.525. Do you guys get that? Somewhere around there. Okay, so if I asked to find each one individually, make sure you're doing that.